In a previous video, we talked about simplifying square roots. We used a factor tree to break down the number under the radical, move any pairs in front of the radical, leave any unpaired numbers under the radical. So if you have a date, leave the house. If you're single, stay home. Here was an example. Now we're going to talk about things that aren't just square roots. What if we have cubed roots, fourth roots, fifth roots, etc.? It's the same exact rules, but instead of if you have a date, leave the house, you have to look at your index here, and whatever that number is tells you how many numbers make up a date. So in my examples below, that means I need to look up groups of 5 in order to leave the house, groups of 4 in order to leave the house, groups of 4 in order to leave the house. So if you don't have 4 of them, you cannot bring it out of the radical. For these problems on your homework, they're always going to end up being whole numbers, either positive or negative. If you take more math classes, that will definitely not be the case. But the hard part on your homework is going to be to figure out whether your answer should be positive or negative. So here's some rules I want to tell you. If it's an even index, this number here is even, this number must be positive. If it's positive, everything's fine and dandy, you're good to go. If it's negative, you must have an even exponent somewhere in there, like raise this whole thing squared, 4th power, 8th power, any even number in order to break it down, and then you would treat it like we did in a previous example, previous video, this problem. If there is not an exponent there, like in this example here, then this is no solution or not a real number. That's only if it's even. So because this is even and this is a negative number and there's no even exponent there to cancel it out, then there's no solution. If it's odd, this number here can be positive or negative. Just when you break it down, bring whatever symbol it is in front. So let's do these two problems. All right, let's find out what the fifth root of negative 32 is. So 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. So no matter what you started with, you should have ended up with 5 2's. Well, we need 5 2's in order to make a date. So all 5 of these 2's leave the house and go on a date, and there's nothing left underneath your radical, so you don't even need to write the symbol. There was originally a negative, and this is an odd number, so pull your negative out front. That's it. For the last example, 625, I break it down, I can pull out a 5. I can pull out another 5. I can pull out another 5. Okay, so I break it down no matter what you started with, it breaks down into 4 5's. Well, my index here is 4, so you need 4 in order to make a date. Luckily, we have 4 5's, so my 4 5's leave the square root to go on a date. Nothing's left underneath my radical because I don't have any single numbers. And there's a negative already out front, so I need to leave it out front. But now the 5 is also out front, so this is just a negative 5. So if this is odd, whatever sign is under your radicand is going to be the sign of your answer. If this is even, if there's a negative under your radicand for these problems, there probably won't be an exponent to cancel it out, so it's not a real number. And if you have a positive number underneath your radicand, if there's a positive here, it's a positive answer. If there's a negative here, it's a negative answer.